All right, thanks everyone. This is my third of 5 presentations at this conference, so if my mind seems to wander sometimes, then I might still be caught up in one of the others. But don't let me get away with it. Stick your hand up and ask me questions, and get clarification if there's stuff that you don't get. I'm going to try and do quite a few demos, but similarly, if you think there's something that I'm skimming over and I need to show you, make sure you make me aware of it. If I can't do it now, I'll do it afterwards. Actually, not right afterwards. So I apologize in advance. I'm not going to be able to stay after the session. I have to go straight to the ballroom for the keynote. We have a run through. So make sure you ask your questions before I leave the room and before the end of the session. Okay, so we're here to talk about security, specifically for, lightweight services. Let's call them microservices, right? We used the word yesterday. And of course, I'm going to be focusing on Spring, but I mean, it's sort of a little bit of a theoretical debate as well about, what's good, what's okay, what you might do, what you might get away with. Did anybody come to Rob Winch's talk in here just after lunch? That was good. So that covered the sort of some of the basics of Spring security and some of the really key concerns, especially to do with HTML sort of user-facing web apps. The services are a little bit of a different beast, and that's what I was trying to convey with the abstract of this talk. So we're not always going to be talking about this, but often one of the problems we have to solve basically is how to convey security information and authorization data between machines. So it's not just a browser talking to an HTML page anymore. There's all this activity in the back end, services talking to each other. And there might be some special concerns there that we need to be aware of and we need to deal with in some way. So let's have a look. This is what we're going to try and cover. What do I mean by microservice? Why is it important? How would it be secure? What would be the sorts of things that you'd want to do? If you were going to use Spring, what tools are available for the different patterns I'm going to discuss. And often the answer to what's the easiest way to get something working is to just install Spring Boot, basically, and just write your business logic. At least that's the goal that we've got. So this is a slide, actually, that I showed at this conference a couple of years ago on a slightly different but related talk. I've updated it, so I've got a new graph for it, and actually Indeed.com trends always look like this. They all seem to dive down a little bit at the end because the data is sort of incomplete. But you can see basically that REST and JSON is a huge upward trend in recent years, and it's actually even more pronounced than it was 2 years ago when I gave the same slide. So that's why it's not just new, it's not just now, right? People are starting to call them microservices now, but the whole thing started 3 or 4 years ago, at least. So what are people going to do about security if they're writing systems like that? And what is this microservice thing? So what I'm talking about when I'm talking about microservices, some people are going to talk about it in different ways and mean different things, but roughly speaking, I'm going to be in this kind of area. I'm going to be usually talking about HTTP transport. I'm going to usually be talking about sending messages and request response in some sort of text-based content, often JSON. Small, compact messages, definitely. Quick responses if it's HTTP. You don't want to be hanging on the connection forever. RESTful is kind of a loaded word. Anybody go to Ben Hale's presentation? I think that was in here as well, wasn't it? Earlier today. That was really good. That's always popular. So Ben's good because he's pragmatic, and so am I. RESTful doesn't mean that you follow the party line to the letter. You just have to be somewhat inspired by REST, right? You have to think about resources and verbs and that kind of thing. So, we have some common understanding about what we mean when we post to /games, which was Ben's example. some degree of statelessness. So people, this is another thing where you get religious wars, and I am going to actually have an opinion on that later on, so I'll hold back a little bit now. But roughly speaking, you want to try and, for operational reasons normally, you want to try and keep things as compact and light as possible on the server, and you don't want to be storing a lot of state. Nothing is stateless, that's the problem really. And I don't want to get on my soapbox yet. So you're aiming anyway for some degree of statelessness, and that's often to do with availability. And then a final concern might be some form of interoperability. So you don't necessarily want all of your microservice clients or microservice implementations even to be written in the same language, and that there's somewhat catered for or taken care of by some of the other things on the slide, but when it comes to security, then interoperability might have a different flavor, because Ruby is a terrible language for dealing with XML, for instance, so anything based on WS star and SAML assertions is going to be a no starter if you've got anybody who's writing Node or Ruby apps. Okay, so what are security requirements? Basically, you want to stop bad guys or bad things from accessing your resources. Okay, so what does that mean? It means identity and it means permissions. You need to identify who's trying to access the resource, and you need to somehow compute a rule that says whether they're allowed to or not. So the key questions are, how am I going to get that information to the service, right? How is it physically going to be transported? And how can I keep it secure while I'm doing it? How can the service, I've got to send it in some form that can't be intercepted and used by somebody else, obviously. So how is it going to be decoded and interpreted? How am I going to make that computation? So what data do I need to make the access to do the rules? And can I actually, can I convey that information efficiently? How is the data managed? Who is responsible for storing and retrieving it? And how do you know at the end of the day that you're looking at the same request that the originator sent? How do you know that somebody hasn't been in there and changed added a zero to the amount that's being transferred or something? So some services are more concerned with some of these things than others, and you don't want to use a hammer to crack a nut, but you do want to be aware of all these things in case you need to solve those problems. So my first point of call is good old HTTP basic authentication. It definitely is something of a lowest common denominator. Everybody can deal with it. Practically all servers, even your front-end load balancer is going to be able to deal with this in some way. It's completely ubiquitous on the client side. And has very good support, consequently, in Spring Security and in Spring Boot. Okay, so Spring Boot will guess that what you want when you build a REST controller is for it to be protected with basic authentication, and why not? So then you can do a very simple access to the resource. You can curl it from the command line. You can use whatever language you want. So what I'm doing here is I'm saying username :password, this is just a common convention that a lot of languages use, at my host / resource. Okay, so that's a pattern for accessing a resource. And in Spring Boot, it would look like this. So I can do my copy-paste demo like I did in the keynote last night. vi app.groovy. I'll switch to Emacs maybe later. How about that? Who would like Emacs? One. Oh. You got a question, yeah? Question? No. No. Who Emacs? Yeah, right. I would get colors with Emacs. I can probably do that with VI as well, but I'm not an expert. Okay, so I'm going to grab the Spring Security dependencies, so this is basically the same app that I wrote last night, but I'm adding Spring Security as a dependency. Okay, so convention over configuration, Spring Boot is going to guess that you want to do something with that. App.groovy. And in a couple of seconds after it started up, I can hopefully demonstrate that it's working. Curl localhost 8080. Right? Unauthorized. Sorry. And I'm getting a JSON response from Spring Boot, by the way, which is a sort of courtesy to say, in addition to the response headers, you've got 401 unauthorized status, and you've got the key piece of information here is you've got a www authenticate header. This is all part of the HTTP basic protocol, basically. It says you need to authenticate, you need to use basic authentication, and your realm is called Spring, and that's something I can configure in Spring Boot with one line in application.properties if I cared to. So how do I get in, right? What's the username and password? And anybody who was at Spring, at the Spring Security talk by Rob Winch will have heard him say, we never configure authentication for you out of the box. Well, that's what Spring Security did. Spring Boot went a little bit further than that and said, okay, tell you what, we'll do it out of the box for you, but we'll make it as secure as we can. So you never forget to be secure. We have a random password, which is in the log file. So I can curl user : random password at localhost 8080 and get my status message. Can everybody see that? Yeah. Okay, so that's basic authentication. Very simple and very easy to do with Spring Boot. If I want to go a little bit further than that, that's basically the journey I'm going to take you on through the rest of the presentation. But that's, you know what? That's not bad. You know, as a starting point, there are a lot of people in the world using basic authentication, and it works. So what is wrong with it? Well, where did I get the credentials from? Yeah, you do need some way of managing that password, right? My default choice here is to create a random one and log it so that anybody who's got access to the log file can get in. So probably we could go with that, right? I mean, that's good enough for a lot of use cases where the log file is going to be in a data center behind a firewall. Nobody's going to be able to see it unless they've got permission. It's not great for how do you find out the password? So what would you do? How would you create a system that you could log into reliably? Anybody got a suggestion? All right, so I've got a suggestion to encode the password. Yep, I might also encrypt it. I might store it in a properties file, encrypted and encoded, maybe. Or I might just make it an environment variable. So the environment variable is something that can only be set by the user who launches the process, right? And that can be a protected account. That's another way that people do it. Also, if you don't or can't deal with encryption, I can show you some encryption stuff, actually. We're going to do that tomorrow. Is Spencer in the room? Spencer and I are giving a talk tomorrow on Spring Cloud, and we'll show you some encryption, decryption utilities that you can use in your properties files. I wasn't going to do that today. Environment variables are great. And the other thing people do is they put their properties files in a user's account that can't be read by anybody else except the user that's running the server process. So you can use Unix file permissions to protect things. Environment variables is probably the easiest, and they work really well with PaaS solutions like Cloud Foundry, Heroku, those kinds of things. But you need to be able to share secrets securely, basically, and so that's a limitation. In practice, that tends to mean you haven't got hundreds of server nodes to deal with or hundreds of different roles to deal with, because it's a management headache. Otherwise, at some point, you'd want to centralize that information. We have some suggestions about that as well, which we'll talk about in Spencer's talk tomorrow. But you need to deal with that problem. So that might be an issue. That might stop you from using HTTP authentication. It might be the showstopper. The other thing is it's only username password. I mean, that's actually part of the spec, right? You take that username password. It's not really username : password at hostname. It's really what curl is doing with that is turning it into a header, right? Which you saw here. Oh no, you didn't. Okay. it would have, oh no, because I didn't authenticate. I need to do -v. -v with a space. There, right? That's actually what it means. It's basic authentication, and that thing there is encoded, but not encrypted. It's a base 64 encoded username password pair. So that's great, but it is only username password, right? You can't add another piece of information. So that, you know, the standard mantra in security, modern security these days, is something you have and something you know, right? So something you know is the password, and you should also, if you're being rigorous about things, try and, you know, include something you have. Maybe something you have is an account which is has a protected access, and that will complete the security loop. But, you know, two-factor authentication, nah, it's not going to work really, is it? Also, it only really covers authentication, so you can convey the, you know, the identity of the user, you know, just a username basically. But you can't, just from that information at least anyway, you can't tell what kind of permissions that user or that machine has got. And finally, the thing that I guess is going to be a showstopper for a lot of these things, there's no fine-grained control over who is actually presenting this authentication header, right? It could be a machine, it could be a user, you don't really know. It's just a name-value pair, basically, as far as you're concerned. And the key thing is it's only one name-value pair. That's the only information it has. So in particular, it can't be a machine acting on behalf of a user. And that's an important concept that we're going to cover later. Okay, so that's HTTP basic. It's good, right? I mean, it's going to work, and it's going to get you up and running and pretty secure very quickly. I'll tell you a story actually about Sagan. You know Sagan, the Spring.io website project key name. When we launched that last year at Spring 1, the day before we launched, up to the day before we launched, we had it on, we didn't have it on Spring.io, the domain name. We had it on a different domain. It was still public, but we protected everything with basic authentication, so nobody could see the website unless you had a password. And you know, we knew that that app was eventually going to be open. It was a public website. We weren't going to protect it with basic auth forever. It was a really good short-term solution. We'll just get it, you know, up and secret so that anybody who's got a password can give us feedback, but anybody else will just find a 401. So that was, you know, that was good. It got us a long way for almost no effort, and that's actually where all those features in Spring Boot came from. Okay, so the next option, actually quite common in, you know, sort of a modern large data center operations, network security. Everything is networking at the end of the day, right? You can control an awful lot by just controlling access to IP addresses, pretty much, and ports. So I'm talking about, you know, IP tables, routing tables, physical and virtual networking. So essentially what you're trying to do is make sure that your service endpoints are not exposed to the internet or to, you know, the corporate public network. They're all behind some physical barrier. And the barrier is basically going to be a separate network, or, you know, a protected network of some sort. And that's very secure, right? I mean, you know, there's absolutely no way that you're going to get packets through to a private network. This is a very common solution for people who deploy on EC2, right, on Amazon Web Services, because they have a nice sort of built-in infrastructure for private network inside EC2, and then you just get, you know, pop up where you want to into the internet and provide a public-facing network interface, which doesn't actually have to be on the same machine even. So that's really good, and it suits that kind of architecture. What I've just described basically is the edge server. The edge server is where you see the public, and it controls access to everything behind it, which is great, okay? Again, nothing wrong with that. It's perhaps a little bit annoying to debug because you can't see the services behind there. You're going to have to find a way somehow to get into that private network to test anything. Often the configuration is not in control of developers. That's a kind of a personal war story, I guess. For organizational reasons, you just don't, as a developer, you just don't get access to configuring the network, probably for very good reasons, for all I know. But I mean, anything that takes control away from developers is a bad thing in my book, because it means that you know, it's different in development than it is in production, basically. So you're always running the risk of things going wrong because it's different. And the other thing is there really isn't that much in the way of authentication per se, right? I don't know who's contacting me. I just know that they had to be in the private network, otherwise they wouldn't have reached me. So it's only good for some problems, not all. I'm not going to demo that one. So the next option I'm going to offer is also quite an interesting one and sort of quite low level, and that would be certificate-based security. It's you know, quite old technology, but it's based on really solid, you know, theoretically solid cryptography, so it should be pretty good, right? Until OpenSSL turns out to be full of bugs, of course, but assuming that kind of thing can be fixed. The basic idea here is that you're using SSL, using the secure socket layer to carry authentication information. So normally when you're using just HTTPS over, let's say, you know, you're paying your bill online with your bank, then they use HTTPS as a protocol for the web browser, right? And so that's over a secure socket layer. But in that case, the server which is accepting your connections, it needs to do a little dance to accept the connection, but it doesn't actually require you to prove who you are, right? It doesn't need you to authenticate. It just needs you to, in fact, it's the other way around. It needs to provide a certificate to say that it's valid. But what you can do is part of the protocol, right? Part of the SSL handshake is an optional exchange of certificates. And so Spring Security has some features built in for that. It's called X509 authentication. And Spring Security basically takes that certificate information that the client sent, turns it into an authentication, which is a Java principle. And then you're off to the races, basically. You're inside your application, and you have your authentication information. So, okay, if this is what you're going to use to secure microservices, so back-end services, then it must be the case then that you have SSL termination actually in your microservice, right? So you've got Tomcat, perhaps, running with a secure socket layer built into it. That's quite possible to do, right, by the way. Nothing so unusual about that, but it's more common, I think, just to run with insecure ports on private networks. So the problem being, well, I'll get to the problem in a minute anyway, actually. So it's in the SSL. The SSL layer is in the microservice itself. And if you're doing that, then you actually already have a key store, right? So you can prove who you are because you can handle HTTPS incoming requests. So if you can do that, you can also use the same key store to send authentication onwards, downstream, right, to the backend servers behind you. So in some ways, this is quite a convenient solution because the certificates are all in place already. Here's an example using curl. So if you wanted to use curl to interact with a secure service this way, you would say, I'm going to use key authentication, and the certificate is going to come from this file, rod.pem, and in curl there's a colon notation again for passwords, so it's a bit like the basic authentication. So I've got a password inside this key file, which can be used to unlock a certificate, and then the certificate will be sent over the SSL handshake when it first contacts this localhost. That's kind of the mechanics of it. I don't have a code sample for that in the slides, but I do have one here if you're interested. It's somewhat of interest. Was anybody at my talk just now with Phil? A few people. So we were talking a little bit about server customization there. Here's an SSL application, which is a Spring Boot application at enable auto configuration. Can everybody see that at the back, Brian? He's nodding. So it's a REST controller. It's going to have a resource called /hello. And the only thing that's different about this than what I already showed is It doesn't have Spring Security. It does have Spring Security installed, of course. It has a customizer for the Tomcat container. So the Tomcat container needs to be customized so that I can add a connector, and the connector is going to be customized by this method down here. So this is a callback that Spring Boot gives you, Tomcat Connector Customizer. So instead of the vanilla HTTP handling normal connector, I'm going to add this HTTPS thing. This is more or less boilerplate. I took it from this guy here, actually. Brock Mills wrote the sample in Spring Boot. And all I did was add one line there. Set client auth true. That just tells Tomcat that you're not just going to accept any connection from any client. You have to actually ask for a certificate and validate the certificate. So it's quite strict. And you won't get away with it just by futzing around with random binary files. You're actually going to have to know what you're doing to make this work. So I could run this, I guess. What am I doing for time? Always goes a bit slow at the beginning. I'm sure it'll be fine. Is that running? There we go. So it's running on port 8443. The slide here tends to suggest that I could actually copy-paste that. So maybe that's the copy-paste part of this demo. No. Because I'm in the wrong directory. Yeah, totally wrong directory. I need to be here, don't I? I love live coding, isn't it great? Source, main, resources. That's where rod.pem is, okay. Hello, all right, thank you. So the way that worked was, I've got all the files in one place, obviously, because it's a demo, but that file, server.jks, is a key store for the server, which includes, in this case, self-signed certificates because it's a demo. But in reality, it should include, certificates signed by a proper authority. Otherwise, the SSL won't actually work. Actually, that -k, that tells curl to ignore the certificate errors, doesn't it? Now I remember how the demo goes. If I do that, it'll barf. Yeah. So because it's a demo, I had to use -k, which is insecure. So that's the key store for the server. And inside that key store is a certificate which has been used to sign the certificate, which is ROD. Okay, ROD is an entity which wants to be authenticated. So I created a key pair for him. I signed it with a certificate that came from this key store, and now I can use it to authenticate. So that's actually pretty bomb-proof. So nothing wrong with that, except, well, unless browsers have all got that certificate installed, which you can do, actually. That's what this is. That's something that you could install in your Chrome or Firefox browser, which would have the same effect as I just had on the curl command line. So unless your browsers have certificates installed, then you're only really doing machine-to-machine authentication. And the big downside basically is that those key stores and certificates, that they have to be managed, and they have to be there, whenever you need them. It's a significantly trivial task if it's done properly, because they have to be protected, right? You can't just have any idiot doing it. And finally, the last thing, again, with all these sort of simple identity solutions, there's no obvious distinction or no fine distinction. When you get the certificate, you can't tell that it was a machine acting on behalf of a user. You only know, what the key value pairs inside the certificate are. And that, maybe you could use that, right? It would be a slightly intricate solution to the problem that I'm posing here. You could encode extra information in those certificates that you could use to make quite complex decisions, actually. But the problem is that they're all binary files and they're all, super secret and managed by a central authority. You can't just, interact with them like a database. They're kind of awkward. So it's great, but there are some practical problems. There are some organizations where this is normal, right? Where they have, processes are in place and they just do it. They just, deal with keys. And actually something I'm not going to talk about today, Kerberos, is another solution that similar solution that people use for, well, authentication of everything, right? I mean, not just services, access to JMS queues and all sorts of databases and middleware and stuff. That's quite a common solution. Where you have the infrastructure for it, you can share the secret information with adequate protection, and you're doing it properly, then that's fine. That's a really good solution. Very secure. So the next option I've got for you is, well, I don't know what to call it really. I settled on custom authentication token. I've seen a few of these things. So the basic idea is, instead of using basic HTTP basic authentication, I'll use something that's, maybe a little bit more flexible. Is some kind of token-based authentication. I'll just make a random identifier. Maybe I'll encode some extra information in it. Maybe some JWT JOT encoding or something like that. And I'll have some central service that's responsible for authenticating users. Primarily, this is normally the use case. I'm thinking of something like GitHub, right, where you log into your GitHub account and you go to the token page and it prints it out on the screen and you copy paste it, and then you've got the thing that you can make into an environment variable, and you can have a machine be you, basically. I can have a machine be Dave Syer quite easily. I just copy my GitHub access token, and then I can access the GitHub APIs through HTTP this way. So you can expose it through a UI. Everybody likes that. You can take that token and you can rehydrate it somehow. You can decode it into what it was originally composed of. And Spring has some, interesting kit for dealing with that stuff. There's a special place in the filter chain that it reserves for that kind of pattern, the pre-authenticated processing filter, and there's an abstract one of them. So you basically just extend a method in that, and you do what you have to do to get the token out of the context, out of the headers, and turn it into an authentication, and then Spring Security does the rest of it for you. I would like to also propose a fantastically easy way of doing this, which is based on, is Rob in the room? Rob Winch, stick your hand up if you're here. He's probably doing another talk somewhere. So Rob has got this new thing called Spring Session. Has anybody seen that already? I know I just mentioned it in my other talk. So Spring Session is, it's a generalization of HTTP session and some specific implementations that are targeted at HTTP sessions. So if you want to, this is why it's interesting for me, is because Spring Boot applications, I need a nice, easy way for them to share session data, basically. I do believe that sometimes things need to be stateful. And so this is a really cool project, because basically you just add a filter to your Spring application, and it then, shares session data. And Redis is perfect for that. So there's a Redis implementation of the session repository, which is what I'm going to show you. I guess I need to get my act together here with, oops, identity. I think I put it in here. Yeah, I did. Okay, so I've got a, fingers crossed everybody, I've got a Redis server that I just started with this. Okay, so Redis is going to start, it's going to use a Docker image called Redis, which is from the interweb, and it's going to map port 6379, which is the standard Redis port, to the standard Redis port on the host. So that basically means I've got a Redis server, and I didn't need to, I can just kill it by hitting Control-C there, and it'll go away and never come back again, which I like. So I've got my Redis server. Let me show you the app. Apps, I guess. So you've got two pieces in this, right? There's a UI, so there's a user-facing piece. which is a Java application. It's a Spring Boot application, which I do in about, what do you think, 40, maybe 30 lines, and most of it's white space. So the key things here are, ignore the main method, right? There's some Spring security configuration. Empty, right? It's empty because I just want to use the defaults that Spring Security gives me now. I'm saying, okay, Spring Boot, I'm fine with what you did, but I'm just going to do it for you. I'm going to do it for you, and I'm going to put it in a special place. So this is a Spring Boot class, Spring Security Properties. This says, put this filter in the chain early enough that you can override everything that Spring Boot is going to do. That's what that's telling it to do. And so I'm just going to get the default behavior, which Rob was explaining just now, and you'll see on the screen in a minute. So the key thing here, I've got an endpoint, a home endpoint, which just takes the session and gets its ID and turns it into a token, basically, so I can read it. That's my developer UI, right? And then the key thing here is a filter, right? So this is Spring Session for you. The session filter takes Redis operations and turns it into a repository for the sessions. Really, really simple. All right, didn't have to do very much there at all, did I? So the main thing is that with this filter in place, what it's going to do is it's going to get into the request cycle quite early and wrap the HTTP request, servlet request. And you know you can always do that, right? So it's going to wrap it in a way that masks off all of the session interactions. So they'll go to this Redis repository instead of to whatever in-memory implementation Tomcat was going to use. So this is kind of cool, right? This is so simple and so easy to use. And I could run 15 of these processes and they would all share the same sessions. Absolutely no bother, right? Nothing to worry about. Yes, question?
You talked about the idea of having your authentication information in a central database. Is that what you're using Redis for? Store your essential?
Am I using Redis to store authentication data in a central location? Actually, yes and no, because I'm not storing the password there. I'm storing the password in my application YAML file. That's obviously for a demo. You would have, in addition to this, you would have a normal database or directory-driven authentication process. The reason I said yes and no is because, so that's the no. The yes is, well, I'm going to store my session keys in Redis, and session keys are authentication data, so make no mistake about it. I'm converting this password into a random key, and that's going to go in Redis. Is the fact that I'm storing in Redis the thing that allows me to authenticate across multiple services, multiple instances? Absolutely. Multiple instances of the same service and different services in the same ecosystem, basically. They're all sharing the same Redis store. That's what I'm going to show you now. So the first thing I can do is log in. So ATAT. Well, this is the default Spring Security login form. That's what you get from this. Any web security configure adapter will give you this. If you want to make it pretty and decorate it, you have to add a few lines of code. But I didn't need that for the demo, so I'm not going to do it. User password, I think, was the password in the file, wasn't it? All right, so I got in. But I don't seem to be getting greeted, all right? So the reason I'm not getting greeted is because the backend server isn't running, all right? There's a backend server which is going to print an ID and a message, and I haven't run it yet, so let's run it. Backend server is in Groovy. It has an endpoint, a home page that's going to tell me hello world with a random ID. It's got the same session filter that the other guy had, but I've specifically wrapped it in a filter registration bean in this case so I can control the order. I definitely want this to go in the chain very early, so I'm just nailing it basically to the beginning of the filter chain. And that's it. That's my main method. So there's a short startup sequence for that. And then if I try and curl it, localhost 9,000 is the resource. I'm getting my friendly 401, right? So it still says that I can use basic authentication if I want to, which I can, actually. But the front-end app isn't going to use basic auth. The front-end app is going to use the session token. All right, so let's get the session token from somewhere. It's here, right, because it's... So if I switch on the developer tools, I'm sorry I don't know how to change the font size down here, but I'll describe it for you at the back. This is the request to localhost that I just sent, and the response headers say set cookie with a session ID, which I'm highlighting, and you can't see at the back, but it's in a random string anyway. So let's just check it's the same one here. So in the latest request, there was actually, here we go, yeah. There was an X token header. I'll tell you why it was an X token header in a minute. That's the key that I want, I'm pretty sure. He said very bravely. Okay, so curl, what do we need? -h, X minus token, that thing. Localhost 9,000 homepage localhost, if I spell it right. There's my message, right? So that's doing it with curl by copying, pasting the essentially what would have been a cookie, but is just the Redis session ID. Now I can show you the whole system working. It's already worked because it's an Angular app. It's actually it's running in the page. It's not actually a refresh that triggers that. So it's already working. It already had its token. The reason it had a token, right? This is the key thing. The reason it had a and the reason it's so simple to set up because everything is set up to work with cookies. And Spring Security, when you've authenticated, it sends a set cookie header. This guy picks up the set cookie header, sets the cookie. Actually, I've had to do a little hack in here. I'll admit, and I'm going to get it fixed, right? I'm going to get the JavaScript guys to help me. What I really need to do here is I have to get my JavaScript client to acquire this token, not that token, the one that I just put in the request there. I have to get the JavaScript client to do that rather than have it rendered in the UI, which is what I'm doing at the minute. But that's doable, right? That's just a JavaScript backend call to get the token. And it's all authenticated because of the cookie. So I had to do so little work. I think that's an interesting solution, right? And it's just using a simple, not very much code even in itself in Spring Session, right? It's a very nice job that Rob did. It's an easy enough problem to solve. So that is an example of a custom authentication token with a really easy implementation. I didn't even need to use the abstract pre-authenticated processing filter because I'm just using essentially standard cookie-based authentication. That X token thing, I'll show you that now. There, so in the session filter, there's a header strategy that I'm saying I want to use a header called X minus token rather than a header called cookie. That's just so that I can basically do it from JavaScript, right? I need to be able to send the header, and JavaScript won't let me set the cookie. All right, so that was really easy. I've also got, I'm not sure if I'm going to have time because I want to get through everything. I've also got a nice, you saw the keynote thing last night, right? Where I did enable OAuth2 SSO. Well, you can do the same thing with GitHub because they have OAuth2. So I could show you an authentication with GitHub with a kind of one-liner as well. All good stuff. Right, so what is wrong with that? Again, nothing. It's a great solution for some problems. So the main thing I'm going to call out again is the lack of distinction, basically, between who the machine is and who the user is, because there's really two parties involved if I'm accepting, especially in the use case I showed you, right, where it's I logged in as a user to a front-end app, and then that front-end app had to contact a back-end. So there's three people or three parties in the contract, and I can only really represent one of them in that token, unless I'm doing something more, right? And what would you do that was more? Well, I suppose that's coming in the next slide, isn't it? But the sort of vanilla implementation is a brainless token, so it doesn't have enough information there. Also, you might point a finger and say it's not a standard, right? So you can't actually say, when your auditor comes around, you can't say, I implemented the Spring session from Rob Winch method, because he won't know what you're talking about. He'll just say, no, go away and use SAML or something, right? Because I understand that. So that can be a problem, right? It's just not something that is codified anywhere as a secure thing, but it is. I guess another disadvantage, although you could work around that, is that I had to collect the user's password. Why is that a big deal? I'll get to that, I guess, in a minute in more detail, but fundamentally, it's fine if you've only got one app collecting user credentials, but typically when you break things down, you break your monolith down, and you're going to want to have multiple different, maybe they look the same, right? I'm sure that's how GitHub is implemented. You see several domains even at GitHub, and they all have the same authentication, single sign-on, isn't it? But if you're doing that, you don't want all of the applications to be collecting user credentials, because then they all have to be equally responsible about what they do with the password. And really, you want to centralize that. So I could take this solution that I've just given you, and I could soup it up so that I could solve that problem. But what I would get, basically, when I got to the end of that process, would be something that was so close to OAuth2 that I might as well have just started with OAuth2, which is now what I'm going to propose, and that's basically the rest of the presentation. So OAuth2 is token-based, right? Just like I did, I curl something in an HTTP header, and I'm going to get access to that resource. And the tokens carry information, and there's mainly almost no information, or almost nothing in the spec about OAuth2 to say what that information is, except a few things, which I'll talk about in some detail. So the resources are actually free to interpret the token content pretty much any way they want, which is a nice sort of looseness that you can use to expand ideas and implement interesting things. What's wrong with it? Well, lots of things are wrong with it, actually. I don't want to list them all. I want to talk about what the details a bit more. One thing that I definitely would raise as an issue here is there's no standard yet. I was going to put a link on the slide, but I didn't get time. There is a draft standard for request signing, and that might still be successful. We don't know, but it's been around for years now. So request signing means that's solving the problem I mentioned at the beginning about non-repudiation, basically. I need to know, if I accept the token, I need to know that it's the same request that was sent by the authenticated user or machine. Okay, quick intro. What's going to happen? So in OAuth2, you explicitly recognize the fact that you've got three parties in the contract, right? You've got a client application, so the terminology is sometimes a little bit confusing. A client is a machine, often a web application, like that front-end server I had in my demo just now. But he's acting on behalf of a user, and the user is often behind a browser, but not always. But explicitly with the user's approval. So the user has to say, I trust this machine. He somehow proved to me who he was, and I now trust him to act on my behalf. So if you've ever used Facebook and clicked on a link in your Facebook stream and been taken to a web app, it often says, do you approve this website to access your friends and family? And so that's the approval process. And you can say no. And if you say no, then that application won't be able to do what it wants to do, which is good, right? It's a level of protection that needs to be respected. Okay, so there are three parties. The authorization server is responsible for minting tokens, basically. Normally also responsible for authenticating users, but doesn't have to be, all right? So it's actually an orthogonal concern. It's not in the spec. Nobody says how you authenticate your users, but you have to authenticate them. That is in the spec. the authorization server makes tokens. The resource server consumes tokens, right? So I want access to that backend resource. I present him with a token, and he lets me in. And then there's the client application, which is the thing that's presenting the token. So there are some common examples: Facebook, Google, Cloud Foundry, which was the one that I did in the demo last night. Okay, so bearer tokens. They're lightweight. They're easy to curl. They're like cookies. They represent authentication, right? You might not be able to decode them as a dumb human, but they are certainly as valuable as a cookie. Any bad guy who stole it could do everything that you could do. So you need to protect them, and you need to require HTTPS for all token-born interactions, unless you control the network, right? And even then, you probably want to use HTTPS. So as far as microservices are concerned, yeah, you can curl it in, right? You curl a header, authorization header. It has this form. It says bearer token, so I'm using an environment variable here, into the resource. So my host, in this case, is the resource server. Token is the bearer token, and that came from the authorization server. I could probably demo that quickly, I guess. So I could curl api.run.pivotal.io/v2 apps, I think is the right place to look, but I'm going to get a 401 anyway. Oh, network's gone. All right, I'm not doing any network demos today. So that would give me a 401, and what I was going to do is copy-paste my Cloud Foundry token that's in my home directory so I could get access to that resource without it, but it looks like it's not going to let me do that anyway. Okay, so probably what I could do instead is demo it this way. Here's my Spring Boot application. Instead of copy-pasting, so what I'm doing is @enable authorization server. So I'm going to build an authorization server, and that pretty much works out of the box as long as you've got Spring MVC sitting around in the class path. This isn't even Spring Boot. This is Spring OAuth2, pure Spring OAuth2 feature. There's no integration with Spring Boot yet. The only thing I need to do is configure a client. Okay, so this adapter, a bit like the other Spring security features that you get, they have this configure model, callback model. So you get this clients thing, and you can create an in-memory or a JDBC or whatever you want kind of client details storage, basically. So you're storing information about clients. Those are the applications. And once that information is in place, your server is ready to run. And I do have one that I can just pull out and run, because Spring Security OAuth2 has a load of integration tests. This is a great place to look if you want to build this kind of system. Just go to GitHub, find Spring Security OAuth2 tests, and they're all there. So the vanilla one is, they've got readmes. You should be able to work out how to make them work. They are Spring Boot apps, naturally, because I want a server to run them. So they @enable auto configuration, and they also @enable resource server. So this one is both an authorization and a resource server, just for the sake of doubt. I mean, in a lot of cases, an authorization server is a resource server, by the way, so it's quite common to do that. But you can also split the responsibilities, obviously. This is the interesting bit, right? So @enable authorization server, it has an authentication manager injected into it, and the reason I do that is because I want to support password grants. So I want to be able to present a password for a user and get back an authentication token, or a bearer token. That's optional, but I've done that in this case. So the only thing that's mandatory is to set up clients. So I've got clients here. And so if I run this app, that's the end of the app, basically, just configuring all my clients. If I run the app, then I can, see it crash. I'm using the port or something, probably, yeah. There we go. I can now curl localhost 8080. Let's say I want to look at, I don't know if the home page is open. Let's have a look. All right, it's not. So that's a 401. So it's an OAuth2 protected resource. It's telling me that I need to present a bearer token with this realm, and it's saying an authentication object was not supplied. So it's telling me what went wrong. To get an authentication token, in this case, I don't need to be a web application because I know that this guy, for instance, is is able to do password grants. So I can just curl localhost 8080/OAuth/token. I can do -d grant type. Oops. This is the OAuth2. Oops, sorry. OAuth2 spec. Let me get that back to something we can all read. Grant type equals password. Username equals user, I think. And that'll be in a properties file, so let me just check. Yeah, user and password. -d password equals password. So all of this is mandated by the spec, actually. And then there's a bit that's optional in the spec, but highly recommended, which is basic authentication for the token endpoint. So I believe that will give me a token. There you go. There's an access token. It's opaque. It's just a UUID in this case. They can be all sorts of things, but this is the out-of-the-box behavior of Spring Security OAuth. And then I can use that token in an authorization header. It's a bearer token with that value, localhost 8080. Hello world. All right, cool. So that was OAuth2 with a password grant from a machine which was a command line. That's what Cloud Foundry does if you do CF login, which I didn't do last night on the stage, but I had previously done it. I was already authenticated. It sends password credentials just like that over the wire. What am I looking for? Slides. Here we go. So what was in that token? The token that you saw was a UUID. So it was opaque. But the resource server was able to take that opaque token and dip into a token store. It could have been in Redis or something. It wasn't. It was in memory. And extract things like a rich set of information, basically. There's nothing in the spec that says what it has to be, but you obviously need to know the client, or who's trying to make this access this resource. You strongly recommend it to include what's called a resource ID or an audience for the token. So as an audience is sort of an OAuth1 and other term. It's not used in OAuth2. So it's kind of tacked on in bits of OAuth2 implementation-wise, but in Spring Security we tend to call them resource IDs. So my resource had an ID, which I think it was telling me in the 401 response. Yeah, so that this is actually the name of the resource that I need access to in that token. Otherwise it won't let me in. That's an important feature, right? So when I'm in the token, I have to actually say who it's for, and whoever it was for has to check that it was intended for them. Also recommended but not mandatory, you can say who issued the token. That's important, right? Because as a resource, I want to know where the token came from. It might be in the right format and have all the right fields in it, but if the person who minted it wasn't somebody I trust, then I shouldn't really be using it. That I could tell you some scare stories about that with actual implementations, actual deployments of Cloud Foundry. Anyway, it's also going to have some information about the user. In that case, the user authenticated with a password, and you're going to be able to tell as a result which user it was that wanted access. And even some form of permission information for the user and the client itself, right? So clients and users can have, for want of a better word, role assignments, permissions, and they can be encoded there. Another choice apart from an opaque token would be a JOT. We also support that in Spring Security OAuth now. it's just, and then you get, the token is not opaque, but it's a JSON object encoded and optionally encrypted. We don't encrypt them by default, we sign them. So what you do is you sign it, and so then the resource server can decrypt it easily, decode it, I should say, easily, and then verify that it came from a trusted source by checking the signature. So that's JWT JOT is a standard for signing JSON objects, basically. So we can just use that to encode some identity information. So you've got things like the user ID there, you've got the client ID, you've got an expiry time. Scope is permissions, basically. And that scope is actually a term from the spec. So when you get a token, you say, I'm client CF, I'm acting on behalf of user ID, nonsense, username, tester, and I want the following scope. So I want to be able to do operations on the cloud controller, on my identity, and I want to be able to change my password. And then that the user can be presented with those choices of things that he will allow that client to do. I'm not going to run the demo of that, but as a simple example, it's the same app with job tokens. They're in the integration tests for Spring Security OAuth. It's almost as simple. The authorization server just has another bean or two, an access token converter, and that's the key thing is, yeah, that's it there. So it gets plugged into the authorization server endpoint configurer. So as soon as he gets an access token converter, he knows that instead of taking that opaque string and giving it back to the client, he has to transform it in some way. And the transformation is to turn it into a JOT token. Okay, so there's the server example on the slides, which we can all read later. Good. So a little bit more then about the data modeling side of that. In the server, you're going to want to keep track of who's asking for what. Okay, so the client and the user are obviously in play. The scopes I said were important. So those are the three ingredients when you get that Facebook dialog page. You know, do you trust this machine, this app, to access your user profile and your friends? Those are the scopes that it's giving you. So it says, you know, your timeline is your scope, is the scope that it's asking for. And basically, if the user approves that client for these scopes, then that gets encoded in a token. So you've got sort of a entity relationship diagram like that. In other words, the token actually itself is a data store, right? So you don't necessarily, with JOT tokens, for instance, you don't need to have persistent storage for tokens because they're being passed around amongst all the participants, and the data is actually stored inside the token. That's what that site's about. It's a token. Another slightly orthogonal approach, actually the one that they use in Cloud Foundry, is to abstract that a little bit and say that I want to save that information somewhere persistent. So I'm going to grant a token, but I'm going to make a record of that, persistent record of that, so that the next time the user wants to do the same thing, I don't have to ask him again. And I'm sure Facebook, GitHub, everybody does the same thing, basically. They have some way of, so tokens are ephemeral, right? They have an expiry. This is just saying, well, beyond the life of the token, I can store that decision and make it, you know, automatic next time the user wants to do the same thing. We have support for that in Spring OAuth now, which because I wrote the original UAA code in Cloud Foundry, we basically lifted that out into Spring Security. And the key concept there is an approval store. It wasn't me that wrote most of the code in Cloud Foundry, actually, it was Vidya. So her name's on the commit log in GitHub as well for Spring OAuth. So basically, the way that the convention over configuration works for that is if you have an approval store as a bean in your application context, then it's going to be inserted into the authorization server for you. And it'll know what to do, basically, because it's really just an abstraction about the token, that it can be used to generate more tokens, basically. Okay, so moving on to the resource server, I did quickly show you that because the authorization server happened to be a resource server, but that is actually an even easier role to play. I pretty much have to do two things. I @enable resource server. I need to have Spring Security and Spring MVC on the path. Actually, I don't need Spring MVC, probably it's just Spring Security. And I need a bean of type token store. So token store, including the name, I can give it a token, it can tell me what information is in it. It doesn't mean it has to be physically backed by persistent storage. It might be something in memory, or it might even just be, in the case of the job tokens, it just decodes and checks the signature and then gives you the token contents. So it's a store in sort of interface terms, but it's not actually a physical persistent store. So you can do that, you can provide a token store, that's one option, or you can sort of go a level above that, which is the thing which consumes the token store. You can provide your own resource server token services, which is actually the trick I was playing. What was I playing? Yeah, I was playing this trick last night. There's in Spring Security OAuth2, which is also a trick we ripped off from Power Foundry, there is there's the SSO sort of toolkit, if you like, the thing I was running last night, was an OAuth2 client which also had a resource server token services, so it's sort of acting a little bit like a resource. And the reason it does that is because that tells you how to decode tokens. So once I've got the token, I can say, what user does that represent? And that's my authentication. So that's what I was physically doing last night with that demo. I think that might be a good place to pause and actually show you that thing. But let me show you the client side of the contract as well. Okay, so the other side of things, @enable OAuth2 client, the recipe for using that guy is, if you @enable OAuth2 client, it will give you this thing, an OAuth2 client context, which is session scope. All right. It's session scope because you've got multiple users accessing this client application, and you want to keep the authentication segregated. Session is the obvious place to put it. I'm trying to think if there's an abstraction that easily fits around that. It probably is because it uses Spring session scope, and I think that's backed by a repository abstraction. So if you don't like HTTP sessions for some reason, get over it. But if you can't get over it, then I think there's a strategy. Anyway, so the thing is you get that thing for free, and you just plug it into an OAuth2 REST template like that. And then the other thing that goes in there is kind of the client's credentials, basically the ID and the password. Yeah, very importantly also redirect URI. So it's part of the spec that if you want to be a browser-based client, like I was in the demo last night, you have to register a redirect URI so that the authorization server can send the browser back to the client who wants the token. Let's see, do I have time to do this demo? I've got a feeling I might just have time. So, let me make that a bit bigger, make it a bit more readable. So the one I showed you last night was that one. Roughly speaking, it's that annotation that I want to highlight anyway. So that will get me a simple UI app with a login screen, and the login screen comes from the authorization server, right? I'm not implementing that. And once that authentication is finished, I'll be redirected back to this app, and I'll be able to get a token. And once I've got a token, I want to send a request to a resource which has got my message server in it, right? That's the thing that I was demoing earlier on with basic auth. Instead of basic auth, now it's going to be an OAuth2 resource, @enable OAuth2 resource. Right. Forget about the other stuff for now. That's part of the demo. Actually, it's not part of the demo tonight. Just forget about it. The main thing for this demo is the OAuth2 client and SSO auto configuration and the OAuth2 resource. So I'm going to run both of those apps basically. GVM, use Spring Boot, Cloud. I do need that because otherwise it won't be able to compile those annotations. Spring run sso.groovy. And I'm going to put it in a, oh, I haven't got the internet. Do I need the internet? I don't need the internet if I'm running, it's too difficult to work it out. I was going to authenticate with GitHub, but since I don't have the internet working properly, I don't think, well, I can try it. Let's see. If I can get to GitHub, then I can try it. Oh, that did look like it's working, doesn't it? Okay, fine. Let's see. So to make the demo work nicely, I'm going to log out of GitHub. So I'm going to run it in a Spring profile called GitHub, which I've set up in a properties file. I'll show you that in a minute. Spring profiles active, GitHub. Don't need to do anything else. And then I'm going to do same thing for GVM, use Spring Boot, Cloud. Normal Spring Boot is fine, it's just those, I've got some cloud features in here that I don't need to demo today. Spring run resource.groovy, okay, and then I'm going to set, probably have to set the same profile, GitHub, and I obviously want it to run on a different port, otherwise it won't start. Server.port equals 9,000. I just thought of a reason why I can't do this. What's the best demo, the simplest demo that could possibly work? Yeah, it's already failed. All right, I'm not going to do it. Ask me later. I will do it in the demo lounge to anybody who comes and asks me, all right? Because I need to get through this anyway. So it was going to be, which presentation did I give this demo? I've given so many demos today and I'm losing track of them. I think it was with Phil in the Spring Boot presentation just now. I gave it was the same architecture basically with the UI, authenticating and then sending a token to the back end. And I was going to do the same thing but with OAuth2 tokens. I will do that for anybody who asks me. Okay, so you only saw the physical interactions for the resource, for the password grant, where I sent the password. It's a bit more difficult to do with curl, but the authorization code grant is really the place to be, right? This is the jewel in the crown, really, for OAuth2. This is why we're here, right? It's got, because it includes all three parties in the contract, and it maintains the right degree of separation between them. All right, so how does it work? The authorization server has to authenticate the user. Then once you've got an authenticated user, the client can say, okay, I want the user to authorize this token grant. And then the authorization server has to interact with the user somehow. Normally that's just a form on a web page or something. Get the approval. And once the authorization server is convinced that the approval has happened, sends a redirect to the client app, and the client app will load a page with an authorization code in it. So it'll be encoded in the URL. It's a one-time token, no format specified. It's a random string, basically. And the client can exchange that for an authorization, a bearer token. And that's the flow, right? So the important thing is that there are some redirects happening, right? So all of this happens really neatly and really nicely if you've got a browser or somebody who can follow redirects. That's all you need, basically. Curl isn't great for driving this flow. And mobile apps, native mobile apps is not really the right place to do this. Native mobile apps, you normally just trust them to know the password and not reveal it, so you use password grants. But anything that's a UI with a web front end, even a web back end, you want to try and use this grant. So the reason I'm saying that is because there is an alternative, right? There's an implicit grant. I'll talk about that in a minute. So once you've got the authorization token, the bearer token, you send it to a resource server. The role of the resource server is then to extract it from the request. It should be in a header normally. Some slightly weaker implementations of OAuth2 accept tokens as request parameters. It's not a good idea for normal operational security models. You shouldn't be sending secure information in request bodies, basically. They should be in headers. It's less likely to leak out in logs and stuff like that. So he decodes it. So that was resource server token services in OAuth2 terms, Spring OAuth2 terms. He makes an access control decision based on the contents of the token. So the token will contain scope, audience, user account information, client information, and you can use that information any way you want to compute the result, basically. And the key thing is the scopes, which is just a string in the spec. And so the resource server and the authorization server just agree on the format of the scopes. And so common choices will be things that sort of sound a bit like permissions or roles. And you're supposed to send a 403 if the token doesn't match your expectations for the resource. Okay, so the authorization server in this has to grant the token, has to provide an interface for users to confirm that they approve. It has to be able to authenticate users so that it can do that, the authorization that is. And then it has to have a token endpoint so it can grant the tokens. Only of that list, it has to do all of those things really, but only the details of 1 and 4 are covered in the spec. 2 and 3 are not. The spec says you have to do it. The spec doesn't say how you do it, which is actually quite a good thing. So it shouldn't be telling you how to authenticate, right? You should be able to do that any way you want. To get all that stuff to work, you need a client registration, which is the hardest thing to understand, but as a new user of OAuth2, the client is sort of a role that isn't really important, but it is really important, to be clear, but it isn't always visible in other forms of authentication, right? So other protocols don't actually have this role particularly strongly, at least anyway. So you have to be able to authenticate them. Generally speaking, that means you're going to have a shared secret. The spec again doesn't say how you have to do this. It has some suggestions. If you're going to do browser-based redirects, you have to register the URI that you're going to be redirected back to. Otherwise, you can have bad guys basically tricking users into approving a token that looks like it belongs to you, but actually they're acquiring it at a different URI. So you have to register the URI. I wrote a blog about this actually. I think it's on the Spring Source blog, so the Spring IO blog now, 3 or 4 years ago. So if you look for my name on the Spring IO blog, you'll find all about the redirect URI and CSRF attacks and stuff like that. I think the keyword is cross-site request forgery in OAuth2. So I explained there basically why this registration process is important. It's also useful as a way to identify which resources can be accessed. In other words, the client ID sometimes tells you, something about which resources it's going to be able to get to. Just like a user has roles, so also a client machine has permission information attached to it. Also, it's often the case that a client is registered by a user, okay, usually a developer. You can do that in GitHub, right? You can go to your account and you can say, click on applications and you can register a new one. And that's what you're doing in this case. You're registering a client, an OAuth2 client. And it'll give you an ID and a secret. More on scope. So they are just opaque. They're strings that are understood by the two parties, the two important parties, the resource server and the authorization server. So they don't have a fixed format. You can do whatever you want with them. Google uses URLs. Facebook uses kind of permission style. The UAA and Cloud Foundry uses a period separated notation to say resource.permission, basically. So the cloud controller read, cloud controller write, there's two different scopes. So that's a useful thing to be able to do, but the spec doesn't tell you anything about it. Neither does the framework, really, because they're just strings. Authentication, I said, was orthogonal. You should be able to do it any way you want, and you can. As far as microservices are concerned, so really we're talking about resource service, right? Those are the little guys who are servicing HTTP requests. The web app clients definitely should be using authorization code grant, right? It's the most clean separation of all the roles. It keeps everybody honest. It isn't really a big deal to do that redirect. So that's what this next line is about. For browser clients with a single page apps, very common these days, if it's really, really, really a single page and you've only got a static HTML page and it can't respond to redirects, then you don't have a choice. You have to use implicit grant, it's called. It's a different grant type. It's much weaker than authorization code grant. So look, if you really can only serve static resources, then fine. But honestly, you should be able to do better than that. You should be able to use the authorization code grant. It's much better, much more secure, much better separation of roles. And it really is just the price of, if it's a Spring Boot app, this is why I'm saying it, right? The difference between serving static resources and dynamic resources is one jar file on the class path. It's like nothing, right? So just do it, all right? Just even if you're doing static single page apps, just have one redirect with a dynamic, server active thing, a filter basically that can just accept the request and do something with it. Mobile and non-browser clients. So if you're on the command line, Cloud Foundry command line, for instance, password grant's the best. It's probably the best suited to those needs. You can also, nothing in the spec about this, but you can maybe modify it slightly so that you can provide extra authentication information. In an enterprise setting, that's been very useful. I've lost touch of all the details of that in Cloud Foundry now, but we do support lots of enterprise authentication scenarios, and they tend to be variations on a theme of the password grant, basically, with extra information coming from SAML tokens, that you copy tokens out of a web browser or something. And then the fifth bullet is definitely interesting in the microservice world. So sometimes you don't have a user, right? There's no user in the picture anywhere. You just have two machines that just want to contact each other. And then we're back to the some of the early scenarios that I showed you of protecting microservices. You don't need OAuth2, but if you've already used it and you've already set up the stack for everything, it's actually pretty easy just to use client credentials to generate tokens, and then it's part of the spec. Everybody understands it. You might as well just use that in addition to all of the other OAuth2 features. So I think OAuth2 is nice because it's got this rich distinction between clients and users, and the users are actually optional. Single page apps, yeah, I've already talked about this. Use the session, guys. Especially with no backend services, right? The authorization code flow is vastly superior to anything else that you might use for a browser-based app. Just use the session. You won't get very much data in it. It will be pretty much ephemeral. There's going to be a cookie, okay? But cookies are special, right? They get special treatment in browsers, special treatment in proxy servers. You really should just use the kit that's there. And Spring Session helps you with that. Okay, I showed you a demo of that earlier on. If you use Spring Session, you don't have to worry too much about being a slave to the application server. One special mention for the use case is you've got a front-end app, possibly, which is authenticating users, generating authentication tokens. Then he wants to contact a backend service, and that backend service wants to contact another backend service and another backend service. So there's a chain of backend calls. How do you authenticate those? It's actually, I think it's an interesting and basically unsolved problem. I know people have different solutions to this, and it's not like people aren't dealing with the problem. It's just that I don't think there's a really clear, crisp statement of an ideal solution to this. What often happens is, and that was the demo that I was going to do actually and didn't, what often happens is you take the token that's generated by the front-end app and just use it, just pass it around, right? I mean, it's a bearer token, and it says something about the user, which is good. It says something about what the user said he allows you to do, which is good. The only disadvantage is, so the flaw is that you're losing all the information about the client, the machines that are operating in this chain, right? So you only know about the first one that got the token. Everything else sort of loses it. So one idea to deal with that then, which I've discussed with people and I'm pretty sure has been implemented, but I haven't actually seen it, is to, at every network hop, you basically exchange the token that you get incoming, you exchange it for something which has the same properties as far as the user is concerned, but has changed the client identity. So I can think of several ways of doing that, and I've seen it done. I've discussed doing it in different ways with various people. So a couple of slides right at the end then, just to talk about other things that I didn't have time for, and there won't be any demos. So OAuth1, we do have support for in Spring Security, full solution at the framework level. There are APIs out there, like Twitter, for instance, that use OAuth1. It's a slightly older standard. It does include request signing, so it's very interesting from that point of view. It's pretty much mandatory. And that's actually the thing that's wrong with it. It's very hard for client app developers. It's notoriously difficult or tricky to set up and easy to get wrong, and it can be very frustrating. If you can be sending requests to Twitter and you eyeball them and there's obviously nothing wrong with it, but Twitter won't accept it. And obviously Twitter can't tell you why it didn't accept it, because that would be a security risk, wouldn't it? So it's extremely frustrating sometimes, which is why it was superseded, at least notionally, by OAuth2. However, some people still prefer it because of that request signing thing. It's arguably a little bit more secure in some ways. SAML assertions everywhere in the enterprise, right? So that's basically the same feature set as OAuth2, except it's all XML, WS star, XML in your HTTP request headers. That's all I need to say, basically. Request signing, though, is standardized, so there are some really good bits for it. It's painful to set up, lots of XML. However, it's worth mentioning, exchanging a SAML assertion which has already been used to identify somebody for an OAuth2 token is a really common pattern and really easy to implement. We've done that, I think, in Cloud Foundry. So I got to the end. In conclusion, what have I said? I've said, what is a lightweight service or a microservice? Why do I think that it is important? Well, we've seen it trending. If you're going to use them, then you're going to want to have some lightweight infrastructure. You're not going to want to send those enormous XML payloads around in the headers, for instance. Security is important, but you don't want it to be difficult. Spring Security, of course, makes it easier, and hopefully I've showed you that Spring Boot and Spring Cloud are making it even easier still. So we're working all the time to do this convention over configuration stuff. It's a problem that lends itself to that kind of thing, because most of the time you actually don't care, right? You just want to be secure, and it really is boilerplate. If I want to secure, if I want to authenticate with GitHub, they provide the APIs. Why, as an application developer, should I care about how physically it gets implemented? OAuth2 is useful, right? Hopefully I've explained enough about that. The main thing that it's useful for is the clear separation of concerns and the granularity of the data that it supports with a fairly loose standard. Okay, so then you've got Spring Security OAuth, and if you're interested in a very solid implementation of an OAuth2 identity management system, then it's open source, right? Cloud Foundry is open source. GitHub.com/cloudfoundry/UAA is the user account and access service, and you can just go and look at the code. It's Spring Security. It's XML. I'd like to fix that at some point. I think we're working on it. Ryan's the product manager. He's sitting at the front there. I do have to go in 30 seconds, so I might be able to answer one question, but that was the last slide, apart from maybe some links at the end. Okay, so you were the first with your hand up.
Okay, so looking at the tests in the Spring Security
Okay, is that the question? Is that the question?
Well,
Sorry, I'm just waiting for a question so I can repeat it.
is it going to work without Spring Boot?
Okay, so the question is, does Spring Security OAuth2 work without Spring Boot? Yes. If you're looking at the samples, those tests, and wondering why are they using Spring Boot, it's really just a vehicle for getting the server up and running. So the UAA that I was describing just now, for instance, isn't yet a Spring Boot application. It's just Spring OAuth2 is just a library, right? It provides the Spring security layer and not the Spring Boot layer. Okay, thanks everyone.